Hey, it's T. I'm one of the geniuses at Ask Xylo. So let's just get started with the live session. So let's get started with the first question. So this was sent in by a student. So this is a grade 12 calculus and vectors question. So it's dealing with slopes specifically, so slopes of tangents. So we're dealing with derivatives. So the question is asking me to determine the point on the graph of y equals 3x over x minus 4, where the slope of the tangent is negative 12 over 25. So first we need to understand what they're asking us. So they're asking me to find points on the graph where the slope of the tangent is negative 12 over 25, which means we need to find the derivative, because if we have a function such as this, the slope of the tangent essentially means what's the rate of increase or decrease. So my derivative is going to tell me the rates of increase and decrease, and it's already told me what the slope is, so I already know it's going to be a rate of decrease. So let's go ahead and find the derivative first, which is y prime. So I'm going to go ahead and use the product rule. So let's say I have f of x times g of x as my function. So again, just to recap what we're doing, so the question is asking me to find the points on the graph where the slope of the tangent is negative 12 over 25. So we have to find the derivative of the function, and I'm choosing to use the product rule. So if I rewrite my function as a product, so I have 3x, and then I have x minus 4 to the power of negative 1. And my product rule essentially says I need to find the derivative of the first term, which is 3x. The derivative of 3x is simply going to be 3, multiplied by my second function, the way it is. And I'm going to add my first function times the derivative of my second function. So my second function is x minus 4 to the power of negative 1, so I have to use the chain rule. So when I do that, I bring the exponent down to my coefficient to give me negative 1. I leave x minus 4, and I reduce the exponent by 1, so 1 minus 1 is going to give me negative 2. And then I'm going to get the derivative of the inside, which is just x minus 4, which is going to be just 1. So all this simplifies to 3 over x minus 4 minus 3x over x minus 4 squared. Right? But we also know that the derivative is going to be equal to whatever the slope of the tangent is, which is negative 12 over 25. So I'm going to write down negative 12 over 25 as my y prime. And then I'm going to try and solve for an x value. So I'm going to use common denominators to simplify my right side. So I get 3 times x minus 4 minus 3x divided by x minus 4 to the power of 2. It's equal to still negative 12 over 25. And then the top is going to evaluate to 3x minus 12 minus 3x divided by x minus 4 to the power of 2. And then the 3x cancels out. And I'm left with negative 12 over 25 is equal to negative 12 over x minus 4 squared. And then I can cancel out the 12s to give me x minus 4 squared is equal to 25. And then x is going to be square root of 25 plus 4. In other words, x is going to be plus minus 5 plus 4. So we have two values for x. We have x is equal to either 9, or we have x is equal to negative 1. Once again, we're going through a question that's dealing with derivatives, and it's asking me to find points on the graph of y where the slope of the tangent is negative 12 over 25. So I went ahead, I found the derivative using the product rule. And then I substituted negative 12 over 25 for my y prime. And then I'm in the process of finding my x's, so I simplified to give me x is equal to 9 or x is equal to negative 1. So they asked me to find the point. So what I do is I go back to my original equation and I plug in 9 and negative 1. So my original equation was y is equal to 3x over x minus 4. So when x is equal to 9, I have y is equal to 3 times 9 over 9 minus 4, which is 27 over 5. And then when x is equal to -1, I have y is equal to 3 times -1, and then -1 minus 4 to give me -3 over -5, or 3 over 5. So my points are going to be 9 and 27 over 5, and then -1 and 3 over 5. So these are the 2 points where my slope is going to be -12 over 25. The slope of the tangent. So once again, if you have any questions you want us to go through, if you have any questions you want us to help, if you need any help with, please send them in. We'll be happy to help you. So we're going to go on to the next question. So this was a grade 9 math question that was sent in. So it's asking us to graph this y equals -2x minus 1 using x and y intercepts. So to recap, x-intercepts occur when my y value is 0, and my y-intercepts occur when my x value is 0. Right? This is my x-axis. This is my y-axis. So when it passes the x-axis, my y value is going to be 0. And when it passes the x-axis, again, my x is going to be 0. Right? So to find the x and y intercepts, I'm just going to plug in y is equal to 0 and x is equal to 0. So to find the y intercept, I'm going to plug 0 into y, and I'm going to solve for what x is. So I have 0 is equal to 2x minus 1, which leaves me with 2x is equal to 1, x is equal to 1 over 2. So my x-intercept is going to be 1 over 2 and 0. And then for my y-intercept, I'm going to plug in x is equal to 0. So y is equal to 2 times 0 minus 1. Y is equal to 1. So my y-intercept is going to be 0 and 1. So I'm going to plot these 2 points on this graph. So I have 0 and 1, which is over here. And I have 1 over 2 and 0, which is over here. And then I'm going to connect the points and try to make a straight line. To find the y-intercept, there is also the common way of, if it's in the form of the slope y-intercept form, which this equation is, I have 2x minus 1, and 2x is going to be my slope, and -1 minus 1, so this is negative. Should be negative, so I'm just going to shift this down. So yeah, if you have a function in the term of the y-intercept form, so I have the slope and the y-intercept, I don't need to solve anything. The equation is already telling me the y-intercept is -1, so I don't essentially need to plug it in, but I should know that at my y-intercept, my x value is 0, and my x-intercept, y value is 0. So this is a grade 12 calculus and vectors question. It's dealing with sinusoidal derivatives. So it's saying to determine the derivative of y is equal to e to the power of 2 sine x minus cos x. So in order to do this, we have to use the chain rule. So the chain rule is in the form of f of g of x. And to find the derivative, I have to find the derivative of f of x in terms of g of x multiplied by the derivative of g of x. Right? So the derivative of the outside function multiplied by the derivative of the inside function. So let's go ahead and do that. So y is equal to e to the power of something. I'm going to replace the exponent u. So the derivative of that is simply going to be the same exact thing. So e to the power of u. So e to the power of x is the only unique function which has the derivative of itself. So, and then I'm going to find the derivative of what was inside my exponent, which was 2 sine x minus cos x. So I have 2 sine x minus cos x. So if I want to find the derivative in terms of x, it's going to be 2 times the derivative of sine is cos x, so I'm going to multiply by cos x, and the derivative of cos x is going to be negative sine x, which gives me 2 cos x plus sine x, which is very similar to what I had earlier, but I have 2 cos x instead of 2 sine x at this time. So now I'm going to put all this together. So again, I'm going to rewrite the chain rule, which was the outside function in terms of the inside. I'm going to find the derivative of the outside, multiply that by the derivative of the inside. So my outside function was just e to the power of 2 sine x minus cos x, so I'm going to keep it the way it is. Sine x minus cos x. And then all of this is going to be multiplied by the derivative of the inside function, which was 2 sine x minus cos x, which is going to be 2 cos x plus sine x. So we're going to work with exponential functions. So this is a grade 11 functions question. So this deals with transforming exponential functions or logarithmic functions. So the question states, an exponential function with a base of 3 has been stretched vertically by a factor of 2 and reflected in the y-axis. Its asymptote is the line y equals 1, its y-intercept is 0 and 3. Write an equation for the function, and we need to tell them the domain and range. So an exponential function usually is in the form of a, and then I have a base to the power of x. Right? The transformations done to this could be a is the vertical stretch or compression. I could have a value in front of my k to have a horizontal stretch or compression. And then I could have a vertical translation up or down. So then I'm going to apply the transformations they've told me. So my function is going to be, it's been stretched vertically by a factor of 2. So I'm going to put 2 in front of my base. And my base in this case is going to be 3. It's reflected in the y-axis. So if it's reflected in the y-axis, I need to make it negative x. So anything in, if I have a function, so I'm going to draw an example. Okay, so if I have a function like this, if I plug in negative into every x value, it's just going to flip across my y-axis. So if they tell me I'm reflecting on my y-axis, I'm just making all my x values negative, which is what I'm doing here. So I'm going to plug in a negative x instead of an x, and then they're telling me it has an asymptote in the line y equals 1. So if I think of the base function or the parent function, which is y equals 2 to the power of x, I have something like this, which gives me a horizontal asymptote of y is equal to 0. If they're telling me the asymptote has been changed to y is equal to 1, it means I have a vertical translation upwards by 1 unit. That means my c value is going to be 1. So I'm adding 1 to the end. So this is my transformed function. I have y is equal to 2, my base of 3 to the power of negative x plus 1. So 2 is going to be a vertical stretch by a factor of 2. The negative x tells me there's a reflection in the y-axis, and the plus 1 tells me there's a vertical translation up by 1 unit. If you send us any questions, we'll be sure to answer them. It might take some time because we do get a lot of questions. So we came up with an equation, and they've told us the y-intercept is 0 and 3. So what we could do is check our answer. So it's going to be the y-intercept is when x is equal to 0, so 0 and 3. So what we could do is just plug in an x value of 0 to see if my y value is going to give me 3. So y is equal to 2, 3 minus to the power times 0 plus 1. So this is going to be 2, 3 to the power of 0 is going to be just 1, 2 plus 1, I have y is equal to 3, so my point satisfies my equation, so that proves that my equation is good. So if I were to graph this, what I do know is my base is 3 and it's reflected on the y-axis, so I have a function that's going to look similar to this. Right. Some points I do know is my y-intercept, which is 0 and 3. And I know my end behaviors because it's reflected. It should go towards negative infinity when my x goes towards negative infinity, and as x approaches positive infinity, it should go towards 0. Okay, so we're going to move on to the next question. So we're still in grade learn functions. We're dealing with exponential applications. So this question is telling me a new car costs $35,000. It loses 15% of its value each year after it's purchased. It's called depreciation. Determine the value of the car after 20 months. Okay, so the usual equation is going to be in the form of y is equal to a times b to the power of x. Okay, so when we break this equation down, a is going to be my principal amount or my initial amount, and b is going to be my rate of change. So my b value changes depending on if it's a growth or if it's a decay. In this case, it's losing 15%, so it's a decay, which means I find the b by doing 1 minus what the percentage of decay is. So if it's 15%, I'm going to change the 15% into a decimal to give me 0.15. So it's going to be 1 minus 0.15 to give me 0.85. So that's my b value. If my b was increasing or it's growing, let's say for example my initial amount is growing by 15%, I'm going to do 1 plus what my growth rate is, so 1 plus 0.15. But in this case it's a decay, so I subtract my percentage that's decreasing every year. So my initial amount, I know it's 35,000, so I'm going to rewrite my equation in terms of the numbers given to me. So I have y is equal to 35,000 times b, which is in this case 0.85, to the power of x. So this x is how many times it's going through that decay. So it's telling me it's losing 15% every year. So this x should tell me the number of years. So they're asking me what's the value of the car after 20 months. That means I need to plug in a value for x and find out what my value is after 20 months. The problem is the x is in terms of years. So how can I convert 20 months into years? I need to divide by 12. So my x is going to be 20 over 12. To give me how many years it is. So I'm going to do 35,000, 0.85 to the power of 20 over 12. So then 20 divided by 12 is going to give me 1.667. It's just a repeating number, so I'm just going to plug that in to find out what my value is. So I have 0.85 to the power of 1.667 multiplied by 35,000 to give me $26,695.18. So to recap, we always use this equation of y equals ab to the power of x. A is going to be the initial amount, b is going to be my rate of change, and x is how many times am I going to use that rate of change. So in this case, my initial amount was 35,000. I have a 15% loss each year, so I calculated it to be, my b value should be 1 minus how much I'm losing every year. So it's 1 minus 0.15 to give me 0.85. And then my x is how many years it's been. So they told me it's after 20 months. So I need to get that x value in terms of years, not months. So it's 20 months. And there's 12 months in a year. So I found out it's 1.667 years. Okay, so I'm going to move on to the next question. So this is a grade 10 question. It's asking me to find the vertex of the equation. So we need to find the vertex of the equation by completing the square. So I'm going to go through the steps for that. So it's usually y, I'm just going to rewrite the equation. Negative 8x squared plus x minus 7. So the steps for completing the square, the first one is going to be, I'm going to factor out a common term, my leading coefficient from the first two terms. So I'm factoring out negative 8 from the first and the second term. So I have negative 8 out to give me x squared minus x over 8 minus 7. I'm leaving my c value the way it is. Okay. The next thing I'm going to do is I need to take this value over here, my coefficient, which is 1 over 8, negative 1 over 8. I need to divide that by 2. So that's going to be negative 1 over 8 times 1 over 2. That's going to equal negative 1 over 16. And then I'm going to square that to give me 1 over 256. We'll see why we do all this in a second, but these are the usual steps of completing the square to find the vertex of an equation. So what I'm going to do next is introduce 1 over 256 into my bracket. So I have negative 8 x squared minus 1 over 8x. I'm going to introduce a plus and minus 1 over 256. So plus 1 over 256 minus 1 over 256 minus 7 on the outside. So I'm gonna factor out the negative 1 over 256 outside my bracket to give me negative 8 x squared minus 1 over 8x plus 1 over 256. When I take it outside, I need to multiply it by the negative 8. Alright, so that's going to give me plus 8 over 256 minus 7. So the inside of this bracket reduces to a perfect square, which it should always, because we followed the steps over here. So when we get that b value, when we divide it by 2 and square it, it's going to give me a value that's always going to give me a perfect square. So my perfect square is going to be x minus 1 over 16, and then I square that. So we can confirm our answers. So if we distribute this x minus 1 over 16 squared, it should give me 1 over 8x and plus 1 over 256. So I still have this to deal with, which is 8 over 256 minus 7. So I have to do common denominators. So I'm just going to multiply 256 by 7 and then add up 8 afterwards. So that's going to give me, my 7 was a negative, so this should be a minus sign. So I end up with minus 1784 over 256. So at this point, we've found the vertex, which is essentially going to be what your negative value of your perfect square is, which is going to be 1 over 16. And your y value is going to be just your constant outside your bracket, which is negative 1784 over 256. So to recap what we did, we're completing the square, so we factor out the leading coefficient from the first two terms. We take the b value that's left, we divide it by 2, and then we square that value to give me a number that's going to get me a bracket that's going to be a perfect square. Then I go ahead, simplify until I end up with something with a perfect square plus a constant number, which gives me the vertex. So the inside number, the negative of that number, I have negative 1 over 16. So the negative of the negative 1 over 16 is a positive 1 over 16. That's going to be my x value for my vertex, and the constant outside is just going to be my y value for the vertex. So we got a similar question. I'll do this one relatively quick. So I have y is equal to 2x squared minus 12x plus 23. So we're going to follow the same steps. So we take out the leading coefficient from the first two terms to give me x squared minus negative 6x plus 23. And then I'm going to take this negative 6 divided by 2 to give me negative 3, and then square that to give me 9. I'm going to introduce plus minus 9 into this equation. And then I'm going to take out the negative 9. When I take it out, I need to multiply it by 2. So I have 2x squared minus 6x plus 9. Negative 9 times 2 is negative 18 plus 23. And then the inside should be a perfect square because we followed these steps. So the inside should be 2x minus 3 squared minus 18 plus 23 reduces to plus 5, and this is my vertex form. If I want to write the exact coordinates for the vertex, it's going to be the negative value inside the bracket. So it's going to be just 3, and the number outside, which is just 5. So my vertex is at 3 and 5. Okay, so we're going to go through this one. So we're asked to solve this expression, and it's dealing with exponent laws. So we have 81 x to the power 4, y to the power 6. And all of that is raised to the 1 over 2. And then I have 8 x 9 y 3 raised to 1 over 3. So what I can do initially is to just distribute my exponent into each of my terms. So I'm left with 81. So 81 to the power of 1 over 2 is square root 81. And then x 4 times 1 over 2 is going to give me just 2. And then y 6 times 1 over 2 is going to be just 3. Right, because I'm multiplying it when it's outside the bracket. So I'm going to do the same for the bottom. So x to the power 9 times 1 over 3 is going to be x to the power of 3. Just to show the work. I'm multiplying 1 over 3 inside, so I have 9 times 1 over 3 to give me x to the power of 3. So once again, we're going through exponent laws. So we're asked to solve this expression. So we're going through and just evaluating the brackets right now. We're distributing the exponent into every single term inside the brackets. So exponents work by, if there's an exponent outside the bracket, when we distribute it, we multiply the exponents together. Right, so I multiplied 4 and 1 over 2, and then 6 and 1 over 2. And then 81 just has an exponent of 1. So it's going to be 81 to the power of 1 over 2, which is 81 square rooted. . So then I'm going to do the same for the bottom. So y to the power of 3 times 1 over 3 is just going to be y. And then I can go ahead and simplify. So the square root of 81 is going to be 9. So x squared y cubed over 8x cubed y. And then we can simplify this further because we can do 9 over 8. X squared over x3 basically means x2 minus 3, which leaves me with x minus 1. Or in other words, I have 1 over x. So I'm going to keep 1x in the denominator. Then for the y's, I have y3 minus 1, which leaves me with y squared. So I'm going to leave y squared in the numerator. Right? And then they gave us some values to plug in. They told me x is going to be 10, y is going to be 5. So now it's a lot simpler just to plug in these values. After we've simplified, we're going to do 9. Y is going to be 5, so 5 squared over 8 times x is going to be 10. Right. This simplifies to 2 to 5 over 80, or in other words 45 over 16. I'm going to just leave it as that. Okay, so that's all the questions for today. Once again, if you have any questions, you need some help with any concepts, you can send us a message. We'll be happy to help you. Once again, just a reminder that our next live is going to be on Thursday, April 18th, instead of the usual Wednesday. And so thank you for tuning in and hope this has been helpful. Once again, this is T from Ask Xylo, and hope you have a great night.